Hello everyone, and in this episode we are going to be talking about JavaScript operators. Now, previously we've discussed that any line of code we write in JavaScript can be considered either a statement or an expression. Some examples of each, some statements we have could be something like declaring a variable called first name using the var keyword and doing a document.writeLine for the string literal hello. Both of those statements are statements because they do not produce a value. They simply do whatever action it is that they're asked to do. Some expressions, on the other hand, things like x equals 9 or tax rate times price, are both considered expressions because both of them would be representative of some particular value. For example, x equals 9, the entire expression would have the value of 9, the value that's being assigned, and the tax rate times price expression would have whatever value was produced by multiplying the value of the tax rate variable times the value of the price variable. Now, something we haven't discussed before is why is it that some statements are statements and others are expressions? There's actually a few different rules that can kind of determine what becomes an expression or not, but certainly one thing that you can always look for is the use of things called operators. Whenever we use an operator in an expression, like the equal sign or the multiply sign, that pretty much guarantees that the line of code in which that operator is used will be an expression, will produce a value. So let's talk a little bit more about these magic little symbols called operators. Operators are something that we see throughout JavaScript. Probably, I would say, a good majority of the different lines of code that we'll write in JavaScript will involve operators one way or another. This is a collection of a handful of different statements I threw together, or expressions, I guess I should say, that I threw together that all involve different operators. And probably at this point in learning JavaScript, a lot of these statements look a little bit complicated to you. But a big part of the key of understanding these expressions is understanding the operators, recognizing them, and knowing what exactly it is that they do, so that you can figure out what each one of these expressions is going to do for us, be able to take a good guess at what the result of that particular expression will be. To simplify this a little bit, let's cut down all of those different expressions and just look at these three, and let's take two of those different expressions and simplify them a little bit so that we can see a little bit more clearly exactly what's going on. The first one, -12, the second one, x equals 9, and the third one, which is a bit longer, are of course all JavaScript expressions involving operators. I've highlighted the operators here in red, but something I wanted to point out before we talk about the operators themselves is that each one of these expressions involves something more than just the operator itself. The -12 statement, for example, has a negative sign, which is an operator, but it also has the number 12 in there. These things that are around involved with the operators are called operands. Every operator has a certain number of operands that it works with, and basically the operands provide sort of the material that the operators are going to actually operate on. Now, every operator, based on the number of operands that it needs, has what's called an arity. The negative sign, for example, would be called a unary operator. It's unary because it only takes one operand. The equal sign, which we would call the assignment operator, is called a binary operator because it takes two operands. And here in the last line, I have an example of the one and only ternary operator, the comparison operator that we have available in JavaScript. So with those out of our way, moving forward to talking about the operators themselves, JavaScript has a lot of different operators involved, a lot of different operators available. So I like to take these different operators and break them up into some different groups. Logical, arithmetic, comparison, and assignment. I think it makes them a little bit easier to tackle that way. Looking first of all then at the arithmetic operators. Arithmetic operators' basic purpose is simply to do math. A lot of these you're probably familiar with. The first four in the list here, plus, minus, multiply, and divide, are all things that I'm sure that you've seen before. The only difference may be that in JavaScript we use the asterisk, sometimes called the splat, to do multiplication, and we use the slash to do division. All four of those are binary operators, and they basically work just the way you would probably imagine that they would work. But we'll take a look at some examples of them here in a minute. The next one, the percent sign, is called the modulus operator. It's a little bit different probably than most of you have seen before. It does sort of third grade division, more or less, where it does the division, but instead of giving you back the quotient, it actually returns the remainder from the division. So it can be handy in a number of different aspects, and we'll look at that here in a little bit. It also, by the way, if I forgot to mention, is a binary operator. The last three, the plus plus, the minus minus, and the single minus sign, are all unary operators. They only take one operand. The plus plus is the increment operator. It basically adds 1 to whatever its operand is. The minus minus is the decrement operator. It subtracts 1 from whatever its operand is. And of course, the very last one, the single minus sign, is the negative operator. It simply changes the sign of whatever its operand is. So let's go on and look at some different examples of some of the arithmetic operators now. Okay, let's go ahead and start off here looking at some of the basics of using our arithmetic operators. As you can see, I've started a default XHTML page, just as I've done previously, and I have the content of that page currently up in my browser so that I can just quickly shift our command tab between them. So, just to give us some place to play, what I'm going to go ahead and do is put some script tags here into the body of my web page. And let's start off in here just by taking a look real quickly using a document write line, no quotes in there needed, at some arithmetic operators. We could do something real simply, for example, like say 34 plus 89. Save those changes, jump back over to my browser, and it quickly and easily gives me the answer of 123. We could certainly also do quite a number of other things. Doing a document.writeLine of two numeric literals is not very realistic. If they're always the two literals being added together, then why not just add them together and display that output all the time? Why put JavaScript through the work? So something that would be much more likely would be that I'd have a couple of variables, maybe variables whose values I know or don't know. So just to kind of show you what I mean, I might have a couple variables, num1 and num2, each of them with a different value in it. Okay. What would be much more common then would be for me to actually take the values of those two variables and perform some type of mathematical operation on them, like adding the two of them together. 77, you can see, is the sum of 54 and 23. It of course doesn't have to be plus that we work with. We could subtract them or multiply them just as easily. Multiply the two together and we get 1,242. Divide the two of them, 2.3478, so on and so forth. So anyway, that's a very simple basic way that we often use our arithmetic operators. You can see that they are all binary. I've got operand 1, the operator, and then operand 2 that I've been using with pretty much all of these that we've been looking at. Okay, so keeping some of those basics in mind, what kind of things could we actually do here with our arithmetic operators? Let's say, for example, that we wanted to write a program that would allow the user to specify a number of days, and then what we want the JavaScript to do is to calculate how far light will travel in that number of days. Let me go ahead and start a new page here. New from template, HTML transitional. There we go. I'm going to call this one speed of light, and I'm going to save it as speed on my desktop. Okay. I could go ahead and open it here in my web browser. Double clicking on it, there's my speed page over in my web browser. Okay. And maybe what I'll do down here in the body for starters is put in a set of script tags. Now, there's a number of different things that this script will need to do. First of all, it's going to need to work with the speed of light. So maybe I'm going to make myself a variable called speed of light with underscores between the words, and I'm going to set it to the speed of light, 186,000, and that is in miles per second. I'll just put that in as a comment to help myself remember the units that I'm actually dealing with here. Now, with that little bit of sort of housekeeping out of the way, the fact that I'm going to need that value, I'm going to go ahead and get it and put it there into a variable. I suppose the first thing the script really needs to do is we need to ask the user about the number of days that they're interested in. So let me go ahead and use a prompt statement. And the prompt statement, of course, is going to return the value the user enters. So I'm going to say var days equals prompt entry number of number of days. You can see my typing hasn't improved any. Alright, at that point the user will enter a number of days, hopefully, and whatever they enter will be returned and stored in our days variable. What I'll need to do then, since my speed of light is in miles per second, is I'll need to change that number of days into some number of seconds. So let me make another variable. I'm going to call it seconds. And what I'm going to do to get the number of seconds is I'm going to take the value of the days variable, that the value that the user entered. I'm going to multiply it by 24, then I'll multiply that value by 60, and then I'll multiply that value by 60. So taking the number of days and multiplying it by 24 will give me the number of hours, multiplying the hours by 60 will give me the number of minutes, and then multiplying the minutes by 60 should give me the number of seconds in that number of days. Once I have that value calculated, the next calculation I could perform then would be to figure out how many miles that speed will actually travel in that number of seconds. So I'm going to make another variable. This one I'm going to call distance, and to get this one I'm going to multiply the seconds times the speed of light. There we go. So whatever distance I'm left with there should be how far light travels, how many miles light travels in that number of seconds. So let me just go ahead and display that to the user. Maybe I'll put it in an alert, and I'll say light will travel. Then I'm going to put in the value of my distance variable, miles in, then I'll display the value of the days variable, and then the word days. So my output should come out, light will travel, 100 billion miles in 4 days, something along those lines. So let me jump back over to my browser and let's see how it works. Enter a number of days. Let's say 4 days. Light will travel, wow, that's a big number, miles in 4 days. Let's try it one more time. Let's say 1 day. Light will travel that many miles in 1 day. So it looks like that works just fine. Alright, for our next little example, let's take a look at an operator that a lot of you may not be familiar with, the modulus operator. I mentioned before that the modulus operator is sort of like doing division, except it's like third grade division in that it doesn't give you back any decimal point, any fractional part to the quotient. Instead, what it always does is it simply returns just the remainder of doing division. So for example, if we were to do a document, some script tags would help, wouldn't they? Let's put in some script tags, and then inside those, let's put in a document.writeLine, and let's put in here something like 9 modulus 2. Now, from what we know about basic arithmetic, we know that if we divide 9 by 2, the answer is not going to come out even. Since we're using the modulus operator, basically what we're saying is, if we try to put 2 into 9, how many will be left over after the division is done? So 2 will go into 9 4 times for a total of 8, which means 1 will be left over. So the value of 9 modulus 2, we will see, comes up as 1, 1 simply being the remainder. If we were to do the remainder of 3 and 2, again the answer would be 1. That wasn't a very interesting example. How about if we do something like 8 and 3? Right? How many times will 3 go into 8? Well, it'll go into it 2 times and there'll be 2 left over, so if we take a look at the output is 2. It always gives us the remainder. Now, you might be wondering, what in the world is something like that good for? Well, in my experience, the thing that I tend to use modulus for the most is for limiting the range of numbers. Let me show you what I mean here. There is a function available to us in JavaScript, and we will discuss functions more later, but really no harm in going ahead and talking about this one now, I guess, called the random function. We get it by doing math.random, along with about 1,000 typos in there. Anytime we do math.random, call that particular function, what it gives us back is a random number. Every time I hit the refresh in my browser and it re-executes, you can see that math.random comes back and gives me a different number. The numbers that it returns, the random numbers that it returns, is always a value between 0 and 1. Right? So if I wanted to do something like, say, simulate the rolling of a regular old 6-sided die, I could do that using this random number, but I would need to do a little bit of arithmetic on it first to get it to come out the way that I want it. The very first thing I might do is I might take the value of math.random and multiply it by 100, just for example. What that, of course, is going to do is basically have the effect of moving the decimal point 2 places. So every time I refresh my browser now, you can see I'm coming up with a number somewhere between 0 and 100 instead of between 0 and 1. So that kind of pulls the numbers up into a slightly more manageable range. Now, I don't really need any of the fractional parts of those numbers, so maybe the next thing I'll do is I'm going to take everything I already have there, put it into a parse int statement, which I believe we've talked about before. That will take that floating point number, that number with a decimal point in it, and we'll turn it into an integer for us. So now we're getting just plain old integer numbers between 0 and 100. Random number, new one coming up every time I hit refresh in my browser. Okay? Now that's still not exactly what I want if I'm going to simulate the rolling of the dice. What I would really need to do next is I would need to limit that number so that it's always between 1 and 6. Now I can't exactly get 1 and 6 with modulus, but what I can do is I can take that number and I can do modulus 6. The way that modulus is always going to work is if we do something like modulus 6, it's going to mean that we can never get back a value greater than or equal to the second number in the modulus expression. So if I do modulus 6, it means the biggest number I will ever be able to get back out of that statement is going to be 5, less than, which is of course less than 6. I probably didn't need to mention that, did I? If you think about it, the way that that works, it kind of makes sense. If there was a remainder of 6, then that would be another full division, which means that the remainder would actually go back to 0. So we can't get 6 or greater, only less than 6 for the value that actually comes back. So if I go take a look at it now, you can see every time I hit refresh, the numbers are all being kind of confined, kind of constrained to that particular range. Everything's coming up between 0 and 5. Now 0 and 5 of course isn't the way that dice usually work, but what I could do to get it just exactly into the right range is simply take that number and add 1 to it, and that's it. Now I'll always get back numbers between 1 and 6 by using the modulus operator, and I have a little expression there that in essence sort of simulates the rolling of a die. So I could write a game with it or do all kinds of other things. I'm sure it will be lots and lots of fun. Alright, let's next go on and take a look at our increment and decrement operators. Like I've done before, I'm going to go ahead and put a set of script tags inside the body where we can play. Now, the increment and decrement operators are both unary operators, as I mentioned previously. They're the plus plus and the minus minus operators. And on the surface, they're both fairly simple. If I were to make, for example, a variable called num, which I'll assign the value of 9 to, if I then came down and did a document.writeLine and printed out the value of num, we would of course see 9 come up. And let me go and add a break on here. If we were to then come down and do something like num plus plus and then print out the value of that variable again, we would see that the value of that variable has now become 10. Right? So by using the plus plus operator on my num variable there, I have incremented the value of that variable by 1. If I had decremented instead, minus minus instead of plus plus, then of course the value comes out as 8. The decrement operator simply subtracts 1 instead of adds 1. So really, on the surface, that's about all there is to the increment and decrement operators, but they do get a little bit more confusing than that. Sorry. Okay. If I were to put in another document.writeLine and I were to say num plus plus right there inside the document.writeLine statement, you might think, okay, it's being incremented, so it will surely come out as 11. But if we take a look, we see that it actually comes out as 10 again. And it almost appears as if the increment operator didn't work at all. If we do one more document.writeLine for that num variable after the one where we did the increment, we see that at that point it actually is 11. What actually happens here is that when we use the increment operator after its operand, basically operand followed by plus plus like we did in that statement and in this statement, JavaScript actually waits to do the increment until everything else in the expression is done. So up here on this line, It was the only thing that happened in the expression, so it didn't make any difference that JavaScript was trying to wait till the end before it incremented that value. But down here in the document.write line, when we did num++, what JavaScript actually did in that situation was it first did the document.write line, and only after the document.write line was complete did it then come back and actually increment the variable. Right? So we ended up with num being 9 here. This changed num to 10. So here num printed out as 10. This changed num to 11, but only after it printed out 10. So when we printed it out here, that's when we actually got 11. So 9, 10, 10, and 11 is what we end up with in our output in our browser. Now, the plus plus and the minus minus operators can actually be used in a slightly different way if we want to. Instead of doing num plus plus, we could actually do plus plus num, which, as you can imagine, is sort of the opposite in order from num plus plus. When we do num plus plus, we call that a post increment. When we do plus plus num, we call that a pre-increment. So, in situations where we want to increment a variable as part of a larger expression or statement, and we want the incrementing to happen first, then we make sure that we put the plus plus before the variable that it's incrementing. We do a pre-increment. In situations where we want the increment to happen last in the expression, we always do a post-increment, making sure that the plus plus comes after the variable. So it can be a little bit confusing, and what I always tell people when they're first getting started with it is that if you're in doubt, just don't include the increment or decrement operators in larger expressions. If I was concerned about what would happen if I did this right here, okay, then don't do that. Basically just keep num out here by itself. It makes the code a little bit longer, a little bit sloppier, and there's certainly some times when that might cost you a little bit, but you certainly don't want to be messing with something that you don't completely understand. So experiment with it, and when you feel comfortable with it, use it any way you'd like. But as long as you're not comfortable with it, or if you suspect that it's causing you problems, then simplify your expressions, keep your increments and decrements out of the overall expression, and it'll make your life a little bit easier. Now, most of the time in here, of course, I was talking about incrementing. All of these exact same rules apply for decrementing the same way. You can pre-decrement and post-decrement, and other than the fact that it's subtracting one instead of adding one, everything works the same way. The next group of operators we want to take a look at then are the assignment operators. They're fairly simple. They all basically have to do with assigning a value, generally to a variable, which will be placed on the operator's left. All of these are binary. They're all going to have something on their left, something on their right. The very first one is the one we'll probably see most often, the single equal sign. We've actually used it a number of times in this class already. It simply takes whatever value is to the right of the equal sign and assigns it to whatever's on the left, which is why we call it the assignment operator and not generally the equal sign. It doesn't really have anything at this point to do with things being equal to one another. The next 5 are all sometimes referred to as being shortcut operators because they simply give us a shorter, more concise way of writing longer statements. We've got the plus equals, minus equals, multiply equals, slash equals, or divide equals, and modulus equals, percent equals. All of those will let us do that particular arithmetic operation combined with an assignment. It's probably easiest at this point to go ahead and just do some examples of those so you can kind of see how they're used. Working with the assignment operators in JavaScript is fairly simple. So simple as, in fact, that we've actually already done quite a bit of it. Like before, I'm going to put some script tags into the body here just so we can look a little bit. The place that we've mostly seen the regular old assignment operator, the single equal sign, used is when we're creating and initializing variables. If I, for example, create a variable called x and I assign it the value of hello, then of course what I'm doing is using the equal sign, the assignment operator right here, to take the value on its right, the string literal hello, and assign it to the variable that's on the left, variable x. I can of course do that multiple times, as we've discussed previously. I could assign, after variable x has been created and initialized, a different value to it, goodbye, for example, which would then replace the string literal hello. Really not much to it. The variation, of course, on the single assignments operator and the assignment operator is to use the shortcut operators. There are times in JavaScript where we'll do things like create a variable called answer, and the variable answer is going to be the result of adding. Actually, hang on, that's not a very good example. Let's just assign a value to answer. Let's give it 9. Okay, and then let's say that I wanted to add 2 to the current value of answer. I could do something like say answer equals the current value of answer plus 2. That's easy enough. But it's a little bit longer than it really needs to be, and that's where the shortcut operators come in, because I could just as easily do that. In the first expression, here the one that's highlighted, what I'm doing is I'm taking the current value of answer, I'm adding 2 to that value, and then whatever the sum of that is being assigned to answer, replacing its old value. Here in the second statement, the one that's now highlighted, I'm actually doing the exact same thing, but you can see that it doesn't require that I repeat the name of the variable that's to the left of the assignment operator. So it can save me a little bit of typing, which means probably save me a few typos. And that's basically how the shortcut operators work. Besides the plus equals, you might remember there was also the minus equals, there's the multiply equals, there's the divide equals, and there is the modulus equals. Any of those can be used in those kinds of situations. There are not any situations in JavaScript that ever require that any of these operators, these shortcut operators, be used, but they do occasionally come in handy. Less typing usually means less mistakes. Our next group of operators then are called comparison operators. All of the operators here in this group are interesting because all of these produce Boolean values. True or false, basically. Anytime any of these operators are used, the result of the expression that they're used in is always going to end up being true or false. The very first of the comparison operators here, the double equal sign, is called the equality operator. What it does is it looks at what's on the left, what's on the right, and determines whether they're equal to one another. Now, when JavaScript checks for equality this way, using the double equal sign, using the equality operator, it ignores data types for the most part. So if we were to check if the numeric literal 9 was equal to the string literal 9, basically a 9 without quotes, checking to see if it's equal to a 9 with quotes, the answer with the regular equal sign would be true. The double equal sign would result in true. It does that because JavaScript will coerce, basically sort of massage the data type to see if it can make the two operands of that operator equal. The next operator, the triple equal sign, is called the strict equality operator. What it will do is it will again check to see if what's on the left is equal to what's on the right, but it will not try to coerce data types. So if the data types are not the same, it will return false and say these two things are not equal to one another. The next two operators after that are the not equal to and the strict not equal to. They're basically the exact opposite of the first two, the equality and the strict equality operators. They simply return false where the other would return true, just the opposite. After that, we have the greater than and less than signs, greater than or equal to, less than or equal to, all of which you're probably familiar with. Again, all of these except for the very last one in this list are binary, and most of them you're probably pretty familiar with, the greater than and less than combinations especially. The very last one, though, the question mark colon, is the conditional operator. It's the only ternary operator in JavaScript, the only operator that takes 3 operands. It's a very special one, and we'll take a look at it here in some examples. All right, next let's take a look at our comparison operators. When I described these to you before, I wouldn't at all be surprised if you weren't left wondering what in the world the purpose of these things is. What we're going to find, though, is that at the moment they aren't going to do a whole lot for us, but here very shortly we're going to talk about another operator, the ternary operator, called the comparison operator, and in a later episode we will talk about control structures. With both the conditional operator and the control structures that we'll talk about later, excuse me, these comparison operators will become invaluable to us, but for now let's just take a look at the basics of how they work. So again, a set of script tags inside the body section, and what I'm going to do here is let me start by creating a variable. I'm going to call it num, like I've done previously. It's just one of my favorite variable names, I guess, and I'm going to assign it the value of lucky number 9. Now, if I'm going to let's say I'm going to put in a document.writeLine so we can actually see the output here, and what I'm going to do is maybe just do the display the output of saying is num equal to 9. Something simple like that. If I take a look at it in my browser, it comes back true. So what's happened here is I've used the equality operator, the double equal sign, and I've asked JavaScript, is the value of the num variable equal to the value of 9? And it, of course, has come back and told me true. It certainly is. Let me add a break in there. Okay, oops, that messed everything up. Interesting. What's actually happening now is that JavaScript is actually adding the value of 9 and the break together and saying, is that equal to num? And of course the answer at that point is false. Let me put some parentheses around num equals 9. At that point the value goes back to being true. The answer, the output from the equality operator goes back to being true. Okay? And let me copy that statement. I'm going to do something like that a number of other times. So anyway, that's the basic equality operator. Let me make another variable here. I'm going to call this one S, S for string. And what I'm going to do is I'm going to put the string value of 9 here inside the variable S. So basically 9 with quotes around it. Now if I were to come back and I were to say is num equal to S, okay, JavaScript in that case would actually come back and tell me true. The reason it's true, like I mentioned before, is that JavaScript will happily coerce data types. Here in this particular expression, num equal to S, what JavaScript does is it says, oh look, this is a number and this is a string. Unless I do something, there's no way those two will be equal. So what it does is it takes the number and turns it into a string because it's a very easy, kind of foolproof conversion. So then at that point it has two strings, both of them with the number 9 in it. It checks to see if they're equal to one another, and the answer comes back yes, they certainly are. If I were to try basically that same thing again, but instead of using the double equal sign, I use the triple, which is the strict equality operator. At that point JavaScript tells me true. Oh, yeah, true. Boy, I'm having a rough day today, because I have the actual number 9 in there. If instead of 9, if I compared to S, in that case, the answer is false, just as it should be. When we use the strict equality operator, the 3 equal signs, that tells JavaScript not to perform any data type coercion. So in this case, it's looking at the numeric literal, or the numeric variable 9 versus the string variable that has 9 in it. Since it's not allowed with the strict equality operator to change the data types around, it knows immediately there's no way in the world these two things are going to be equal. But like you saw a moment ago, sort of on accident, if I compare the numeric variable 9 versus the actual numeric literal 9, in that case JavaScript comes back and says true. Those two are equal to one another. Okay? Most all of our different comparison operators work basically the same sort of way. I could say, for example, is the value of the num variable greater than 10? The answer, of course, will be false. 9 is not greater than 10. I could say, is the value of the num variable less than or equal to 9? The answer in that case, of course, would be true. It is less than or equal to 9. Stress on the equal to part. So most all of our comparison operators work that same sort of way. They're always going to return a Boolean value, true or false. And that true or false value is something that's going to become very, very important to us later when we talk about the conditional operator and control structures. Next, let's take a look at our conditional operator. It is kind of a strange one in JavaScript because it's the only operator we have that is ternary, that actually takes 3 operands. Let me throw some script tags here into the body and let me show you what I mean. The conditional operator itself is the question mark and colon symbols used in combination with one another. The way these two are actually used is you start off before the question mark with something that produces a Boolean value. So maybe to represent that here, I'll just put Boolean inside some parentheses. That Boolean value, or that expression that produces a Boolean value, is then followed by a question mark. Following that, we then have some statement or operation that we want to take place if the Boolean value is true. That true value is then followed by a colon, and after that we then have some condition or operation that we want to occur whenever the Boolean value is false. So it's kind of an interesting one, a little bit more complicated than a lot of our other operators, but it does open up a lot of very interesting possibilities for what we can do with it. For starters, let's say we create a variable and we call it answer. Right? Then we could say something like answer equals, and then we could do some type of operation, some kind of statement or expression that produces a Boolean value. So maybe just for simplicity's sake, let's say 9 is greater than 7. I'm going to follow that then with a question mark. And if 9 is greater than 7, then whatever it is that follows this question mark, that is what will actually end up being the value of this expression. So let's put bigger there. I'm then going to follow that by a colon. This, of course, then is the false section. So if 9 is not greater than 7, this will be the value returned by the expression. So let me put in the string literal smaller there. If we then do a document.writeLine and we print out the value of answer, right, what's actually going to happen in this script is, of course, we start off by creating the answer variable. We then execute this expression. When we execute this expression, JavaScript is going to check to see if this expression that's highlighted now produces a true or a false value. Now, of course, you and I know that 9 is greater than 7, so that's going to come back as true. Because it's true, what's going to happen is this value is what's actually going to be become the value of the overall conditional expression. So bigger is what will then actually be sort of returned, I guess you could say, and assigned to the answer variable. If we were to have swapped this around, for example, and said if 9 is less than 7, then when JavaScript checked this, it would of course find that to be false, which means it would then take the value of smaller, and that would become the value of this expression, the thing that would be assigned then to answer. Let me put it back the way it was initially, where I checked to see if 9 is greater than 7, so answer should come out bigger. And if we take a look at that in our browser, sure enough, that's exactly what we get, bigger. So that's basically the way that the conditional operator works. A little bit more complicated, like I said, but could be potentially useful. I will mention that I'm not a super big fan of this conditional operator. I think it's kind of cryptic and difficult to read. Some people would call it concise, but I think it's just a little bit more complicated than it really needs to be in the way it's actually written. Plus, I burned my hand once on a conditional operator when I was a small child, and I've never really forgiven them for that. Yeah. But anyway, there's a number of other things, of course, that we could do with them. We could take the value of some variables. So maybe I have some variables called num1. Maybe I'll give it a value, 56. And we could pretend, for example, that that value would actually come from a user. Maybe they'd entered it into a prompt, or we'd pulled it out of a form or something along those lines. Well, we could then maybe do something like, say, if the value of the num1 variable is greater than 100, then what I want to do is I want to do a document.writeLine and print out, let's say, that's a great number. Right? Or if that condition is not true, then what I'll have it do instead is do a document.writeLine and print out your number is lacking, something along those lines. So more or less, we could, like I've done here, instead of actually getting the conditional operator to produce a value which is then assigned to a variable, we could actually have the conditional operator, based on its true or false value, decide which of two statements to actually execute. If I come over and actually run this, it comes back, of course, and tells me your number is lacking. I neglected to put a break in there, which is why it showed up on the same line as bigger. But it did function just fine, so we can use the conditional operator for doing those sorts of things as well. Okay, I have reopened our Lightspeed program that we wrote a little bit ago, and I wanted to show you how we could potentially use the conditional operator in this little program to improve it a little bit. Before we actually improve it, though, we need to actually understand what's wrong with it. If you'll remember, if I switch over to my browser and hit refresh, it lets us enter the number of days. I say 12 days, for example, and it comes back and tells me approximately how far light will travel in that number of days. But what happens if I hit refresh, run the program again, and instead of typing in a number, what if I just hit OK without entering anything at all? Well, what the script actually does right now is it will take the nothing that I entered, basically, run it through all of our calculations, and actually come back with a value of 0 for the number of miles. Really not disastrous. The program doesn't crash, but the output is likely to maybe confuse some people and make them wonder, hey, what went wrong? So let's see if we can fix that first of all. Right. What I could start off by doing here in the code is maybe here after the prompt statement where I actually get the number of days, I could put in a conditional operator that looks for that empty string that's actually returned whenever the user just hits OK without entering anything. And if it finds it, maybe put a more appropriate value in its place. So what I'm going to do is I'm going to take my days variable and I'm going to assign to it a value that I will then return from a conditional operator statement. So I'm going to say if the current value of the days variable is equal to the double equal sign, the equality operator, if it's equal to an empty string, just two quotes right next to each other with nothing between them, then I'm going to say return the value of 0 instead. Okay? If the value of the days variable is not an empty string, then we don't want to lose what the user actually typed in. So if days is not an empty string, I'm just going to say return the current value of the days variable. So if the user enters an empty string, basically doesn't put in any useful value at all, we'll get 0. Otherwise, we'll just keep the current value of the days variable. So let's see how that works. Back to my browser, refresh, enter the number of days, 12. Okay, in our good case, with good input, it still works just the way that it should. If I run it again, though, and I just press OK, then it comes back and it says light will travel 0 miles in 0 days. So it makes it make a little bit more sense to the user. Hopefully they'll understand that since they didn't enter anything, we just took that to mean 0. Could be better, and maybe we'll fix it up more here in just a little bit. But there's another problem along those same lines that we might also want to fix. If I hit refresh and it asks me for the number of days, and instead of typing in something or hitting OK at all, what if I click cancel? Right? Then it comes back and it tells me that light will travel 0 miles in null days. What actually happens with the prompt statement is that if we get out of it by clicking the cancel button, the prompt statement actually returns the value of null. So we could test for that and again take a more appropriate value just like we had with the empty string. So back over to the code again, what I could do here is just like before, assign to the days variable a value based on whether days is equal to null. Remember, null is sort of a value data type thing all to itself. We'll run into it occasionally in other places. Now, if days is equal to null, let's do the same thing where we'll take the value of 0, otherwise we'll take the value of days. And let's see how that works. All right, enter a number of days. If I put in 12, everything works fine. Run it again. If I put in nothing and just hit OK, we get 0, like you would expect. If we run it again and we hit cancel, we again get 0. So there we go, we fixed it up the same way. Now there is one other thing that we could do to maybe make this program a little bit more friendly using the conditional operator, and that is that if we end up with a value of 0 in the days variable, which could happen if the user actually enters 0, if the user enters nothing and presses OK, or if the user hits cancel, then what we could do in that situation where we have 0 days is maybe we could decide to display a different statement instead of the light will travel so many miles in so many days statement. So what I'm going to do for this then is I'm going to declare a new variable down here towards the bottom of my script before I do the alert. I'm going to call it output. And what I'm going to do then is I'm going to again put together a conditional statement, and this conditional statement is going to help us decide what the value of output is going to be. So basically what I'm going to say is if the value of the days variable is equal to 0, then what I want it to do is to make the value of the output variable, you should enter a more interesting number. And if the user doesn't enter 0, if we actually do have another value in there, then I will stick with the same basic output line that I had before. I'll just copy it out of the alert statement and paste it in here instead. Then, down in the alert statement, I'm going to instead now just display the output, display the value of the output variable. So we work our way down through the script. We create our light speed variable. We ask the user for the number of days. We might get a number. We might get a null. We might get an empty string. If we get a null or an empty string, we set the days to 0. We then go through and we do all of our calculations. We create our output variable. And then we say, if the number of days is equal to 0, right here, okay, then you should enter a more interesting number. Otherwise, we display the output from our calculation, or assign that to our output variable anyway, and then actually display the value of that output variable here in this alert. So let's see how that works. If I type in a number of days, everything works just the way it should. If I just click OK without entering anything, it says you should enter a more interesting number. If I click cancel, you should enter a more interesting number. So everything seems to be a little bit better at this point with this script. Everything's a little friendlier and working a little bit smoother because of the use of the conditional operator. Now, there are, of course, other little problems in this script as well, like what happens if it asks me to enter the number of days and I put in Victrola, right? Then it comes back with light will travel NAN, it's called, miles in Victrola days, which certainly doesn't make any sense. But maybe we'll save fixing that one for later when we talk about functions. The last set of operators then we have to take a look at are the double ampersand, the double pipe, and the single exclamation point. The first two, the double ampersand and the double pipe, are called the default and the guard operators. They're also sometimes referred to as the and the or operators. They're both binary. They both do logical operations, producing some value which can usually be seen as a value or as true and false. We'll need to come back here maybe in an addendum to this particular episode and talk about truthiness and falsiness. But we'll take a look at those here in just a second. They're very useful. And then the last one, the exclamation point, is a unary operator. It takes a Boolean value, true or false, as its operand and simply reverses it. So, of course, if we were to say not true, the answer would be false, and if we were to say not false, the answer would be true. So let's look at some examples of these. Next, let's take a look at our logical operators, of which there are only 3, so this won't take too terribly long. As before, script tags inside the body section. Now, our logical operators are the exclamation point, which means not. We have the guard operator, which is also sometimes called and. It's a double ampersand. And we have the default operator, which is sometimes also called the or operator. It's a double pipe. In case you don't know it, the pipe symbol is usually on the same key as your backslash. It basically looks like a vertical line. Sometimes it has a little bite out of the middle of it, but that's called the pipe. Now, let's take a look at the not operator first. It's really the simplest. It's a unary operator, and all it does is take any Boolean value and reverse it. So if we were to, for example, say not true, okay, then the answer we will get back is false. If we were to say not false, then the answer we get back is true. Boy, that's complicated, isn't it? Every once in a while that not operator comes in handy, but in general, I believe you should try to avoid it. It can get a little bit confusing when you have nots thrown in, a much larger, more complicated expression. Just like people don't like nots in multiple choice tests and things like that because it confuses them. You should try to avoid using it in your code too. Sometimes you'll run into a situation where not using it will cause you a whole lot of trouble, in which case I'm kind of pragmatic when it comes to that, and I say go ahead and use it. But don't use it when there's just as easy of a solution that doesn't involve using the not operator. So anyway, that is the not operator. Now, the guard and the default operators are a bit more interesting. Let's start off here, for example, by doing a document.writeLine, okay, and putting in, let's say, true and false. Okay? The double ampersand a lot of times is called the and operator because it operates very much like the word and does in the English language. When we say one thing and something else, of course what we actually expect is to get both, and the and or guard operator is the exact same way. So here when we say true and false, basically what we're doing is we're giving it something that's true and something that's false, which will not make the and operator happy. The and operator wants everything to be true. So when we say true and false, what we will actually get back as a result is false, the and operator being unhappy more or less. If we were to say true and true, if I can spell true, then that will make the and operator happy and it will come back and tell us true. But if we were to put false in this statement anywhere, false and true, true and false, false and false, all of those with the and operator are going to end up returning false. Basically, the only way to get back true with the and operator is to put in true and true. Now, of course, it's not very realistic that we actually put true and false here. What would be much more realistic would be something like where we have a variable, let's say x, that has a value, good old 9 again, and we were to say something like if x is greater than 0 and let's say x is less than 10. Now, both of those sort of sub-expressions, these two comparisons, the x greater than 0 and the x less than 10, each of those will be evaluated first, producing their own true or false value. Those true or false values can then be worked with by the guard operator, the double ampersand, the and, whatever we want to call it here. So here in that case, since x is 9, x greater than 0 is true, x less than 10 is true, so true and true will come back and give us true. There we are. Okay. Now, the second, or I guess the third actually of these operators, the default operator, the double pipe or operator, whatever you want to call it, works very much like the guard or and operator does. We could start off by playing with it here just a little bit. We could say something like, for example, true or false, okay, which will come back in this case and give us true. Now, the double pipe, the or the default operator, basically the way it works is again very much like the word or in the English language. If we say one thing or something else, then we expect one or the other, but not necessarily both. So with the or operator, as long as there is a true as one of its two operands, then it will be happy and it will give back that true. But as long as we don't end up giving it sort of a double false, a false on both sides, that would be the only situation where we actually end up getting a false if we do something like false and false. That's like saying give me hamburgers and pizza and getting a sandwich. It's nothing at all like what you actually wanted. And just like we were talking about before, it would be fairly unrealistic to actually be putting in Boolean literals here. Instead, we would probably have some other type of little sub-expression using comparison operators or something along those lines that we would be using instead. Okay, so anyway, that's what those three operators appear to be on the surface, and the not operator is really just that. It doesn't get a whole lot more complicated than that, actually. But the guard and the default operator are actually a little bit more interesting. Let me show you this, for example. If we were to do, let's say, well, we already have a variable x. Let's just go ahead and use the variable x we already have. Let's say if x is equal to, and let's put in a true or false. Okay. Then let's do a document.writeLine, document.writeLine. Boy, getting even worse. X, what we would of course get back there is true. So really all we've done at that point is we've taken the or operator out of the document writeLine statement, assigned its value to a variable, and then printed out that variable. But I did it that way because I wanted to show you something else that we can do with these operators that can be kind of interesting. For example, what happens if I were to put 9 or false? On the surface, that kind of doesn't seem like it makes sense as long as you're thinking of the double pipe just as being an or operator, because 9 and false are really sort of different things. How can they be compared that way? But what we haven't discussed, and maybe we'll need to come back and discuss a little bit more later, is that just about every value, every literal, every expression in Java, besides producing a value like we've been working with and seeing, can also be evaluated as being Boolean, can be evaluated as being just true or false, like the number 9, for example. The number 9, of course, is just the value 9, but JavaScript also sees that value as being true. So if we come over and we take a look, we can see what we actually get from our default operator now is actually the number 9. So we find that the default operator here, the OR operator, the double pipe, is actually doing a little bit more behind the scenes than we realize that it is. If I were to say do 9 or blank, it comes back and gives me 9. If I were to say blank or 9 that way, I still get 9. You see, the way the default operator is actually working is that it will always return a value that it considers to be true over one that it considers to be false. So let me go back and show you one other aspect of it here. If we say 9 or blank, we get the 9 back. What happens if I say 9 or 10? Okay? Whenever we give it two things that are considered to be true, like 9 or 10, then it always gives us back the first one, the one that's on the left, in this case, 9. Right? That can actually come in handy in a number of places. You might remember in our Lightspeed example where we had something like a prompt. Here I'm going to tell the user to enter something. I should leave them guessing, huh? If I were to then say x equals x, or I said enter something, a string, okay? Then what happens when we actually run this program is it says enter something. If I put in something like a number or a string, okay, then it comes back and it actually gives me that string. But if I leave it blank, it says I entered something. If I hit escape or hit cancel, I enter something. So what's actually happening here is that we're taking the return value from prompt and we're putting it into the x variable. Okay? We're then saying x or this string. Now this string is always considered to be true. All right? It isn't an empty string. It's considered by JavaScript to have a true value. So really what's going to determine what the result of that expression is what the value of x is. If I actually type in a value, then that value is also true. So JavaScript sees this as being true, and it returns the first one, which is just whatever we entered, whatever was stored previously in x. But if I just hit enter and leave it blank, or if I hit escape, which we know results in a null, both empty strings and nulls in JavaScript are considered to be false. So in those two situations, when the value of x comes back false, it takes the true value instead, my string over here, and assigns that to x. So that's what I get when I actually print it out. The guard operator actually has that same sort of second level to it, that hidden work that it's doing. The difference is the guard operator, the double ampersand, or what I was calling before the and operator, will always return the false value or the second value. So kind of exactly the opposite of the or. The or always returns the true value or the left value. Okay? The guard operator always returns the false value or the right value. So sometimes those come in handy, and I think we'll probably come back and explore this a little bit more in the future. The only last thing we really have to talk about then with operators is that operators must obey a precedence, basically a ranking. Same sort of way you've probably talked about operator precedence in, say, an algebra class. In algebra, they actually teach a little mnemonic to help people remember operator precedence. How's it go? Please excuse my dear Aunt Sally, I believe is the operand, or the mnemonic they typically teach in the algebra class. Basically, please excuse my dear Aunt Sally, what it means is that parentheses, P for please, is the highest precedence. It always happens first. So parentheses in any expression will always be the first thing that's evaluated. Excuse is exponents, which we don't really worry about too much at this point in JavaScript. My is for multiplication, second level of precedence. Dear is divide, Aunt is addition, Sally is subtraction. So anyway, if that helps you remember operator precedence, then that's a good way to help remember it. But here's a little chart that just kind of breaks down all of the different operators and a couple of the common functions that you're going to run into in JavaScript. You can see that indeed the parentheses are at the very top level. They always will be executed first. On the second level, we have some of the other operators we've talked about, plus the type of function that we've discussed in a previous episode. After that, we have our multiply, our divide, our modulus, followed by addition, subtraction. Then we start running into a lot of our comparison operators, less than or equal to, greater than or equal to, followed then on the next level by the equality operator, the not equal to operator, non-equality operator. We then have our guard and our default operators. Then we've got our assignment and all of our shortcut operators. And then the very lowest level of precedence in JavaScript operators is the comma, which we will not see used very often at all.